Zoe's doing her homework at home. That's interesting. And a dog bit off a piece of the paper. All she had left was the sequences. The sequence. Oh, all she had left of the sequence was the first and the fifth term. Was term 1 and 5 shown here. So, um, in fact, I want to sketch this as a table. So I'm looking at the first term, second term, third, fourth, fifth, sixth. And I know that the first term is the number 96th, and I know that the fifth term is the number 486. So the first question is could this be an arithmetic sequence? And actually, yeah, it could be. And in fact, because I only have these two terms, the first and the fifth term, you can think about it like this. I've got 2 points, right, on the Cartesian coordinate plane if I want to look at that, visualize it this way. So through those 2 points there's a line that goes through them. So I could definitely construct the line that would go through those 2 points. Another way I might want to choose to look at this is if I start at 96, I'm going to have to add a value once, twice, 3 times, 4 times. So I'm going to add the same value, and I don't know what it is, but I'm going to add the same value 4 different times to get to the number 486. In fact, um, what is that number that I need to, let me clear this calculator. Um, so let me take 486, and I just want to subtract from that 96. So when I look at that difference, I can see it's 390. And I need to grow from 96 to 486 in 1, 2, 3, 4 steps. So I'll just divide that by 4. And I get a 97.5. So what I'm adding each time here is 97.5. So that's the rate at which I'm growing. And if I start at 96 and add 97.5, add 97.5, I should land at 486. Now, maybe you've noticed this, but what we're really doing here is I'm essentially finding the slope of this line, right? I'm taking 486 and I'm subtracting the number 96. That's how much I have to grow by. And then in my denominator, I'm taking 5, the fifth term, and subtracting 1. So I have to grow a total of 390 units in 4 steps. So that's equivalent to this arithmetic. So yes, this most definitely could be an arithmetic sequence. And if it were, I should figure out the rest of these numbers, right? So I would start at 96, and then I would add to that 97.5. When I do that, I'd land at 193.5. So this is 193.5. And if I add to that again 97.5, I'm at 291. That's great. Plus 97.5. I land at 388.5. And just for a check, I'm going to go ahead and add the last one. Whoops, clear that. So I'll say plus 97.5. And if this was perfectly, we should land at 486. And we do. We land at 486. So the final question here is if so, find the explicit rule for the sequence. So could it be arithmetic? And fill in the explicit sequence. So the one thing I'm missing here is my 0th term. I know the first term is 96, and this isn't hard to find, right? I'm just 96, and I'll subtract from that 97.5, which is interesting. It's at negative 1.5. So this, I guess I'll just write it in y equals form. Y equals, every single time I'm growing by 97.5, that's what I'm adding. So let me multiply that by x. And then I'm going to take away 1.5 because my 0th term is negative 1.5. So that's the rule that I would have for this sequence, and it's perfectly happy to be an arithmetic sequence. The next question is, could it be geometric? So I'm gonna go ahead and sketch the same thing again here. So now I'm thinking, could it be a geometric term? So first, second, third, fourth, fifth terms. This is 96. I'm told this last one is 486. And now instead of adding the same thing each time, the question is, could I multiply So that's 1, 2, 3, and 4. So could I use repeated multiplication to get from 96 to 486? Um, and I don't see why not. I'm not sure what I'm going to multiply by yet, but I should be able to do that. In fact, if I think about this, if I start at 96 and I multiply by some value of x, I don't know what it is, but I multiply it by 1, 2, 3, 4 times, I need to land at the number 486. This I don't think we've looked at these this way yet this year. This is interesting because if I wanted to, I could rewrite this as 96 times x to the fourth power, and that equals 486. Um, if I divide both sides of that by 96, let's see, 486 divided by 96, I get I get x to the fourth power has to be 5.0625. Okay, so fabulous. What's x? Hmm, um, I know that I'm jumping ahead. I think this is chapter 8. I don't know why I've decided to do this. I think you guys can find this in other ways, but let me talk about this anyways. I think that we understand that if we have a power raised to a power, we multiply. So just consider this. Here's x to the fourth, and what I want to do with x to the fourth is I want to take that and I want to raise it to the 1/4 power. Because remember, a power to a power, I multiply to figure out what this is. So if I was to multiply on this side of the equation, right, I would get x to the 4 times 1/4, which would be just x to the first power, or just x. So if I raise to the 1/4 power on the left-hand side, I need to do the same thing on the other side. So if I raise this to the 1/4 power, I should get the value of x. So let's see if I can do that on the calculator easily here. So that's the number, and I'm going to raise that to a power of. I think the calculator's fraction key would work here. Let me try this. Oops. This. No. Don't do this. I want to try it again. No. I'm using the wrong ROM right now. So I'll just do this. I'll raise it and I'll just open parentheses and then 1 divided by 4. Or I could enter 0.25 also, right? So here I go. I've got this base raised to the 1/4 power, and it gives me what? It gives me 1.5, 1.5. That's a nicer number than I expected it would be. So apparently, I could start at 96 and just continue to multiply by a half, and I would end up landing at 496. So I'm going to say definitely yes, this could be geometric. Even if they weren't nice numbers, it clearly could be geometric. Let's go ahead and find out what the nice numbers are though. So 96 times 1.5, that gives me 144. That's nice. And then times 1.5, that gives me 216. Times 1.5 gives me this fabulous 324. Whoa, not 344, 324. And then times 1.5, and that gives me 486. Checks. So did a great job of moving from 96 to 486 using repeated multiplication. So the last thing we're going to do is write out our explicit equation. Again, I need the 0th term. So if I look at this, I'm multiplying by 1.5 to move forward. So I'm going to take 96 and I'm going to divide by 1.5. And when I do that, it gives me the number, 64. So my 0 term is 64. So my equation should look like this, and I'll write it in y equals notation. Y equals my 0th term, which is 64. Every single time I'm multiplying by 1.5, and I'm going to write that as a fraction, 3/2. I like how that looks. So y equals 64 times, keep multiplying by 1.5. How many times do you multiply? Well, it depends on the term number you want, right? If you want the first term, x would be a 1, and you just multiply it by one of them. If you wanted the second term, you'd do it twice. This is supposed to be 144. If you want the third term, fourth term, the fifth term. So just by way of demonstration, if I wanted to know the fifth term, I can see it what it is, right? But I want to just check this formula. So if I take 64 times open parentheses, I'll do 3/2, and I'm just going to raise that to the power of 5. As soon as I do that, my calculator says 486. That's great. Perfect. All right, that is it for question number 4.